Hi everyone, welcome to today's webinar on inline color measurement and closed-loop color control in the paper industry. I'm Robert Grotans, the Global Technical Marketing Manager at X-Rite. I'll be moderating today's webinar. Presenting today is Manfred Binder, our Sales Director for Inline Color Measurement. I'll turn it over to him to kick things off.
So hello. Today I want to show you how efficient it is to have an inline color measurement for the brown paper industry. What is so important to talk about color? I mean, if you look at a package like this is a regular storage room where I take the picture at a very famous Swedish furniture supplier. So if you look at these packages, they all have different colors, especially the ones on the top. Which package would you like to pick? What do you trust is a good quality? Or if I look at these packages, they have also different colors. A small one and a big one comes together as a package. But do you really trust in the content of the package? Or this is a shelf where we have our folders inside. Look at the folders. Does this look like high quality? So the problem is that color is a primary quality criteria. You do not have to be a specialist to recognize that there is something wrong. And this is the reason why we say color is so important. It's the first glance what you get of a product. If you look at the paper industry, what causes these color variations? We have the raw material. If you have a recycling paper, if you have waste which you use to produce your new paper, these recycling stuff will vary in color. You have different fillers from different locations, clay, calcium carbonate, whatever. So these raw materials are also changing in color. You have different additives, fixing agents or retention agents. If you add more or less, it will result in different colors. Of course, the pH value will change the color and the dye stuff concentration as well. So if you look at the paper machine, at the beginning, you have lots of variations of incoming products, but at the end, you want to have one specific color. So this is the big surprise, let's say, on the paper machine. If we talk about color measurement, it doesn't mean that we measure only color. You see, for different products, we have different measurements. If we have laminated paper or kraftliner, testliner, we only measure color. But for newsprint, for tissue, for graphics coated and offset paper, we have also the opacity, which is very important. And if you go to all these white papers or white coated boards, the whiteness is as well as important. So everything which we see here, we measure with our systems. In total, we have over 700 successful installations in paper. And when I say successful installations, the paper makers are very well connected to each other. So if you know somebody using our system, you can ask everybody how our system is working. Normally, our installations are very well, and people are very happy with these installations. So I do not fear if you contact somebody having our system. But we are not only in paper, we have also other systems like for plastics, coil coating. So in total, we have 1,000 systems, but you see the majority is on paper. Why is this inline color measurement so important? If you have a paper machine, normally you can only take a sample at the end of the reel. So you can take the sample when you have a reel change, you go to the laboratory, you can measure it in the laboratory, and then you know what you have produced the last 45 to 60 minutes. Only with the inline color measurement, you see immediately what happens on your machine. As soon as there is a little change on the machine, you see it, you can react, and you can do something against it. It helps you to start up the machine. So especially if you start up the machine or if you have a shade change going from one color to the other, you can typically save 50% of time. If you save 50% of time, of course, this also reduces 50% of waste material. You can react immediately, even before the color is out of spec. You see that there is a change on your machine, you can react, and before going out of spec, you can do something to bring the color back to the target. You have a documentation of the entire production. What does it mean? I mean, if you sell your paper to a customer, sometimes customers complain and they say, you know, at the beginning of the reel and at the end of the reel, the color was in spec, but in the middle of the reel, it was different. If you have the system, you can prove the good quality of your paper, and these problems will not occur anymore. And of course, only if you have a measurement on the machine, you can make a closed loop color control. If we talk about systems, that doesn't mean that we have only a piece of software and an instrument. It's much more. A system means that you have also a frame. So we make a tailor-made frame, which is adjusted to your machine, that the system fits into the machine. You will see later on, this frame will open up when there is a paper break. So you can easily feed up the fresh paper on the machine. As soon as the paper is on the machine, the frame closes, the measurement starts, and you have the actual color values of the system. To do so, we need, of course, some control boxes for the frame. We need a power supply. And we have then a long distance to the computer, which is up to 500 meters or approximately 500 yards. So the computer is typically in the control room. Then we have a regular, very simple computer, which needs only a USB connection. And then we have we call it an ECX box, which is the interface to the computer. It converts the USB signal to a CAN bus signal to go to this long distance to the machine. If we have a closed loop control, we also connect dye pumps. This could be connected directly to our system or through the DCS system, which you use. And of course, we can have a connection to the DCS system, which is bidirectional. So we can give you the LAB, the color values of the paper, or you can send us the standard of the new paper if you go from one production to the other liquid. Fortunately, the color values do not correspond to the finished product. The paper is wet, it looks completely different. But if there is a color change in the pulp, there will be for sure a color change on the finished paper. So we call this a kind of early warning system. Additionally, you can also measure optical brightness, but yeah, only if you if you have a white test liner, then it could be interesting. For the brown test liner, this is not interesting. How does the system look like? Basically, it's the system. It's our ERX50 instrument, which is built in a box. And we have a U-tube over here where the pulp goes through. It has a special design that the pulp does not stick on a window. There is a glass window where we measure through. So this is a very easy to build in system because we have just a small bypass, and this is approximately 1 inch, a 1 inch tube where you can measure then the pulp. This is used if you have, for example, 2 pulp lines. So if you have one pulper which has let's say a waste paper, and you have one pulper which has a nice brown paper or a better quality, then you can adjust these 2 flows, so the cheap and the more expensive pulp, to get to a certain color at the end of the chest here. Or of course, if you have a mixing chest where you do it manually, which is now I would say old-fashioned, you can see if every chest is the same like the chest before. So this is a picture how it looks like in the production line. It just fixed somewhere on the chest. The second place to measure the color, and this is I think the much more interesting way, is right before reel up. So we measure right after the drying section between the reel up, and here typically there are all the other scanners of who measure moisture, thickness, content, and all this stuff. So as I said, this is the most used location. And when we talk about kraftliner, we have here an excellent correlation to the laboratory. So typically we measure here exactly the same values like your laboratory system measures, because we correlate our measurements to the laboratory. Means even the target values are the same, and the delta values, of course, will also correspond. And even here we could measure optical brightness, but of course only for white coated test liners. This is how our system looks like. You see the frame. So if there is a paper break, the instrument swings away. And it's built for really also to retrofit old machines for very narrow locations. So this is quite narrow and quite easy to install. This is now a previous system, an older system, but we are very proud about this because here we measure a transparent paper, which has an opacity of only 20% and includes optical brightness. So this is, I would say, this is the high-end exercise what we can do to measure paper. Again, a brown paper installation, and you see this is already a bit dusty and dirty, but the instrument measures fine. And this is what I told you, we are very close always to the scanners right before or after the scanner. So this is the typical measurement location. This is a Gemini system. That means if you have two pulp flows where you have multi-layers on the machine, so we can measure the top layer, we can measure the bottom layer, and we can even control both layers separately. So that means we have one instrument on the top, one from the bottom. If there is a paper break, both instruments move away, so there is enough room to feed the new paper, and only if everything is fine, then the instrument closes again. This is how it looks like. So normally when we go to the installation and make pictures, then everything is nice and clean. So this is directly at the installation or short after the installation. So if the instrument is running for a time, it could look completely different. This is now in a tissue machine. You see everything is dusty over here. This is the instrument. Here you see the measurement spot. And the measurement spot is closed. So this instrument works pretty fine. Only during the measurement, by the way, this is in parking position, so this is swing away. There is no web at the moment here. The web would be down here. So if there is no measurement, everything is closed over here. There could be no dust inside the instrument. For the measurement, we open the slit for a very short period. We have an air window over here, and we have also air connected over here, which goes from inside out. So you see everything here is protected by an airflow, so there will go very little dust inside. I would say in the kraftliner process or in the kraftliner mills, you do not have to clean the instrument during the production, maybe once a year when you do the service, or every calibration period, which is approximately 6 weeks. In the tissue mills, it's more often, you have to do it every 8 hours. But you see, the instrument is very clean, very stable. No problems with dust. This is how the measurement looks like. So we have here 3 axes. We have the L axis, we have an A axis, we have a B axis. These are the color values. And you can have 3 more axes, which gives you additional information. In this case here, we have a delta E, and we have an opacity over here. You can have a whiteness over here, whatever you like, so up to 6 values. Every measurement is a new bar over there, and it moves in that direction. And it's very easy to see how the color looks like. If you look at the last measurement, it's a little bit too light, a little bit too green, and a little bit too yellow. Here, it was too blue, too red, and too dark. So on the color of the bars, you can immediately see which direction your color deviation goes. That's a very easy view. Everything is controlled with the buttons over here. So the customer does not have to go through menus or do something difficult. You start the measurement, you can pause the instrument, you can continue the measurement, you can change the frequency of the measurements, and this is the correction to adjust the inline measurement to the laboratory. So it's really easy to use. A training for operator typically needs 20 minutes for color measurement. And if you talk about the closed loop control, it takes approximately 1 hour. After 1 hour, a regular operator can use the system. This is now, again, a paper machine. Now we have a brown paper on the machine. We have the measurement right before reel up. And this is the whole closed loop color control. So far, I was only speaking about the measurement, showing the results on a computer. But now we try to close the loop and we say, okay, we know where we are. We know where we want to be. So we can calculate how much do we have to change the dies at the beginning of the process. We send this information to a pump control unit in this case. We control the pumps. We have die containers over here. So we control the flow which goes in over here. If we see that the paper is too red, we reduce the red a little bit. The paper goes through and we see immediately how the red goes out of the paper. So this is the closed loop control. And I think very important to say here, this closed loop control is a mathematical model. So you cannot use a PID controller or something like this because you have 3 dies. Unfortunately, these dies do not go each color to one axis, so it's not possible to use a PID controller. This is really a mathematical model which calculates all 3 dies in one step. What you can do if you have very deep color shades, you can use, for example, a brown or whatever and make a pre-dyeing over here. This has the advantage that you can use very cheap dyes. You can put them in, they have a long contact time. So you bring the color over here up to 90%, let's say, of the coloration, and only 10% you do with direct dyes over here and make the closed loop control. If you look at this window, so this is what everybody loves to have. You have one die which is influencing the L axis, you have one die which is influencing the B axis, and you have the A axis, excuse me, and you have one die which is influencing the B axis. But of course, in practice, this does not work. So each of these die influence all axes. If you add, for example, more red, the A value will get more positive, but the L value will also get down. And if the red is a yellowish red, the B value will increase. If it's a bluish red, then the B value will decrease. So it will influence everything. And this is the reason why we have to have a mathematical model to control these 3 dies. Especially if you have an OBA because you make white shades or whatever, the white shade is also influencing all of these dies. It makes it even more complicated. So why does a closed loop control help you to produce much quicker the paper? Why can it save so much time and so much money? Basically, we have two things which help you. One is the time for the startup of the machine or even for the shade change. The traditional way is if you start up the machine, the paper makers try to adjust everything. They try to adjust the pulp flow, the width of the paper, the caliper, the chemistry, pH value, everything needs to be adjusted at the beginning. All of these values influence the color. So this is the reason why only when they have adjusted all of the other parameters, they will adjust the color, because the color does not influence these parameters over here. So it takes a certain time if you start up the machine until you are finished and have a good product on the machine. If you use a closed loop control, it's a little bit different. Of course, we cannot influence this part over here. This is exactly the same. But if the paper makers see, now we need only 5 or 10 minutes to be on the right, let's say to have the right physical properties of the paper, then they start the closed loop control in parallel. Means it's just pressing a button at this time. The closed loop control adds the dies, it adjusts everything, it goes to the right color. That means typically if the paper maker is finished with his setup of the machine, the color is finished too. That means all of this part over here will help you to have a good production, which saves you a lot of money. So this is the interesting part, how you can save money. And I show you later on a second one, which is especially in brown paper. let's see, what do we need if we make a closed loop control? Of course, we need pumps. We need to have liquid dyes to add the dye continuously into the process. These pumps can be any pumps which are available. So it could be piston pumps with stroke adjustment, without stroke adjustment, membrane pumps, mono pumps, peristaltic pumps, gear pumps, whatever. The only thing what we recommend is that the pump can start from 0. So if you have a pump which starts at 10% only, then you miss the point if you go to 0. And this is important because sometimes if the pulp gets very dark, we reduce the darkest dye, which is typically a black or a blue. We take it out and we control just A and B. But then if the pulp gets lighter again, we need slowly start with the blue or with the darkest dye. So if we can just decide whether 0 or 10%, you can imagine this will be a ring at the end of the row. So you will see it immediately. So this is the reason why we recommend using pumps starting from 0. What is also very important, we have a database of all the colorants you will use. We are working very close with the dye suppliers. The dye suppliers give us samples of all their dyes. We make the database for their dyes. So if we come to install the system, we have a ready-made database with us. You do not have to make any samples or preparations to train the system. The system is ready to use. So the dye suppliers love us. They work very, very nice with us together because it makes even their life easier. If they want to change something on the machine, they can just change the LAB values and the rest is done by the closed loop control. They do not even have to do it by themselves. I promised you, maybe first of all, there are several ways how to dye a brown paper. So some people say we want to have only one dye, one brown, which makes it very easy because you can adjust more or less, so you can move along this way. If you have the target over here, you need a certain amount of dye to go from your pulp, which is over here, make it more brown and end up over here. The problem is, if the pulp is changing, if you have a pulp like this, using the same dye, you can only end up over here. If you have another pulp which is over here using the same dye, you end up over here. So you can never go to the target. That's one of the biggest problems. The better idea is to have 3 dyes. So let's say we have a yellow dye, we have an orange dye or a red dye, whatever, and a blue or a black dye. In this case, we can adjust all these different pulps to one point. If you have a pulp which is more yellowish, you add a little bit more red and then you go to this direction. If you have a pulp which is a little bit reddish, you add more yellow and you come to that direction. If you have a pulp which is too light, you add more blue and then it gets darker, and you can adjust the A and the B value with the yellow and the red. So every pulp which is in this range, you can go to your target exactly, not only close, but exactly. And when I say exactly, I would say typically it's 0.1, 0.2 delta E maximum. So the control of L, A, and B is only possible if you use 3 different dyes. And all of the dye suppliers have different systems. Some are using a brown, some are using an orange, some are using a red. Yellow is very common, of course. Some using a blue, some are using a black. It doesn't matter. We know, you tell us what dyes you use. We have the calibration data for each of the dyes, and you can go on. And if you want to change to another dye supplier, just let us know. You get the new calibration data free of charge, and you can continue with another dye supplier, achieving exactly the same color targets. So what is possible? If we have 3 dyes, then we can go to a delta E of 0. If you have optical brightener, we can use up to 3 dyes. Typically, you have just 2 dyes, a blue and a violet, and an optical brightener to achieve a delta E of 0. So we control the L, or the delta L, the delta A, and the delta B values. If you use less than 3 colorants, then also closed loop control is possible. But of course, we have to decide what to control. For example, we can control the L and the A value and let the B value float. Or very typically, we control the A and the B value and let the L value float. Because we have 2 dies then, but 3 unknown, so we can just adjust the A and the B value, for example. And as I mentioned already, we are working very close with the die supplier. So the die supplier gives us not only the samples, they also help us to define the position where we inject the dies into the system. So this injection point is very important because we want to have it as much as possible at the end of the machine, at the head box. Then we have a very short response time. But on the other hand, we need some time that the die goes onto the fibers. So this is a responsibility of the die supplier where we work together with them. Now I promised you to show you how you can also save a lot of costs with brown paper. I have just chosen here one axis. So let's say this is the L axis. If we want to have a target of 58, typically in the brown paper industry, the limits, the tolerances are not that tight. So you have typically plus minus 2 delta L, let's say, tolerances. What happens in a regular paper industry or paper mill if you have no closed loop control? The die supplier, the paper makers always want to have a nice brown paper, so they add more and more dies to make the paper nice brown looking. At a certain point, the controlling comes over and they say, you know, we are much too expensive. We have to reduce the die. So it goes up to this value over here. But of course, by time, the paper makers start to add more and more brown to make it darker because it looks much better, it looks much stronger, it's a very much nice paper. So this is a typical process, what you see in all the paper mills. It goes up, it goes down because of process variations, but also because of paper makers like to have a nice brown paper. The problem is if you send all this paper to your customer, the customer complains because sometimes he has a very light paper and he has a very dark paper. It doesn't matter whether the paper is over here, when it's always lighter, perfect. When it's always darker, perfect. But what he doesn't like is sometimes he gets a paper like this, sometimes he gets a paper like that. He wants to print a nice red on the paper, and of course it always looks different. So he needs always to adjust his color to the different basic colors of the brown paper of the Kraftliner. So if you have a closed loop control, it looks different because the closed loop control always brings the paper to the target. No matter what variations you have at the beginning, if you use darker paper, lighter paper, whatever, it always stays very close to the target. So this is how this curve will look like. The customer will be very happy because he gets always the same color. Is that much? 59.5. You get exactly the same curve like here over here, but it saves you a lot of dies because every 1 delta L in lightness saves you approximately 7% of your die usage. That means if you go 1.5 points higher, you are by far within the tolerance. Your customer says, perfect, I have a nice paper, it's always the same shade, and you save approximately 10% of your dies. And if you think now how much dies you use per year, and you can save the 10%, you will see that the return on investment of the paper is only done by this calculation within very short time. So the advantages of the automatic closed loop color control. Of course, it provides on-time process correction. You do not have to do anything. The paper maker just clicks on a button, the closed loop control starts, it will bring the color to the target and it will keep the color on the target. This will minimize for sure the startup time and the shade change times. And of course, it will minimize the off-spec production because if you're faster on your target, you have more good paper to sell and you have less waste. The uniformity of your product is much better because even if you put variations at the beginning, like waste paper, like recycled paper inside, The closed loop control keeps the color constant. So you will have always the same shade. You can reuse all your waste, reuse all your recycled fibers, whatever. The quality or the color quality of the paper is constant. As you have seen in the last slide, you can optimize your dye usage. That means if you make it a little bit lighter, still in specs, but a little bit lighter, you can use a lot of, or you can save a lot of time, a lot of money. Then it takes the guesswork out of the process. If you have a good colorist who does it manually, he knows maybe, okay, we have to add now a bit of blue, but how much is it? 1%, 2%, 3%? Maybe we start with 1%. It's not enough, so we add another 1%. Maybe another 1%. The closed loop color control will calculate that you need 2.8% to get to the right color. It adds the 2.8% and you are on the right color. So this is a very nice feature. It takes the guesswork out of the process. The operators can focus more on optimization. So when is an operator really in trouble, or when is it a lot of work? If the paper machine is running, then it's easy. There is not much work to do. If they have a shade change, if they have a paper break, if they have a startup of the machine, then they are busy. And exactly on that time, they need also to change the color. So it's very difficult for them to do everything on the same time. That's the reason why typically this is sequenced. So first they do all these mechanical parts to get the paper on the machine, and at the end they do the color. If you have the closed loop color control, it does the color in parallel, and this will save a lot of time and makes good production. And of course, it minimizes the tear out of samples because you have all these measurements right on time. You can see what your color is. There is no need to make a real break, a real change, take out the sample, go to the laboratory and confirm that the paper is good or not. You can see it immediately. Let's talk a little bit how to bring the dyes into the process. So we need liquid colors to dose them into the system. Only with liquid colors we can use pumps and say we want to add 1% more, 0.5% less, whatever. We also say never inject really concentrated dyes into the process, because if you have these concentrated dyes, they fix or they stick on some fibers, and at the end you have a kind of marble process. So some fibers are darker, some fibers are lighter. We have to dilute the dyes at the end, but this dilution has not to be in the tank or whatever before we pump the dyes. So pre-diluting dyes have some real disadvantages. If you buy the dye from your dye supplier and if you have it in an IBC, it has a shelf time of approximately half a year or even 1 year. So you can leave it over there and nothing happens to the dye. The problem is, as soon as you put water inside, you have a precipitation. Some crystals are falling out and will stuck everything, valves, hoses, whatever you have. So this is the high risk. Additionally, if you do this pre-dilution, you need to have labor work. You need to have a bin or whatever where you put the dyes inside, where you measure the water, and the concentration is always to be the same. Of course, this is the source of error. If you do this automatically, it's a huge money. It costs sometimes even more than a full closed loop color control system. So this is also a cost-intensive thing for having a non-stable dye. I show you a process which is maybe even better. So what we do is we have the concentrated dyes. So here we have our IBCs. We have a blue one, an orange one, and a yellow one, for example. We take the dye out. We have a pump over here, and then we can go a long way up to an injection point. So here we have the pulp stream and we have the fan pump. What we do is we put here a hose inside this pulp stream where we put some, it's called here transport water, but you can also say dilution water inside. And then we pump into this line. So this line is only about, let's say 5 inches or 10 inches, something like this. So it's very short. These lines go inside. We have a pressure sustaining valve over here, not to get the water back. and then the water goes into the process. The water and the dye go into the process. If it goes in here, and we have the big fan pump here, this fan pump is mixing everything quite well. So at the end, you have a very homogeneous pulp. So this is the idea what we have. If you switch off the pumps now, there is no water inside. So either here or within the pump, you can leave the dye for 1 week, for half a year if you want. There is no precipitation, there is no problem. The only problem would happen over here, but when you switch off, you let the water flow for a while and then everything is clean. So the better way to those liquid dyes is use pumps which have a very small volume to have the right amount of the dye into your system. This will help you to have the best achievable storage time. So the dyes can be kept into the pumps. You do not even have to clean the pumps for a long period. So we have customers, they say they do this, they clean their pumps once per year, but normally they leave it inside. If they switch off the machine, the dye stays into the pump fine for 1 week, then they start again, and then it will work again. If you have this injection point with this small tube where you add some water, if you use approximately 30 liters of water per minute, which is less than 10 gallons per minute, you have a dilution of approximately 1 to 2,000. This is by far enough. So there's no concentrated dye going onto the fibers. You will have for sure no marble effects. If you use anionic and cationic dyes, you have to use separate lines, but even this is possible, so it's not a big deal. We have many years of experience with dosing amounts, and really you can get pumps which have few milliliters per hour as a maximum volume, up to several hundred liters per hour as a volume. So there are a lot of pumps available. If you look a bit closer to this injection point, so this is one idea which could be handsome to use the dyes, let's say. So if we have an IBC, we have a mother and a daughter container. From the daughter container, it's always connected to the pump. So this is like you have seen before. We recommend to have some filters over here. I would recommend to have 2 filters with 2 valves. So if one filter blocks or needs to be cleaned, you close this line, you use this filter. You can clean up this filter, then you set it back, and next time you clean this filter and use this one. So this is a very easy way how to make it. You have some valves over here. We have a dosing pump over here. Then we go the long way up to the injection point. This is the tube which goes inside the pulp. Normally we recommend to make it like this or to bend it a little bit, whatever. Then we have another valve over here, because if this is a really long way and you want to pump through first time, you need to open it somewhere to see if the hose is filled or not. Then you have only to pump these little things. So at the beginning, you switch on the pump, you wait until the dye comes out here, then you close this valve, open this valve, and it goes directly in here. You do this for all the different dyes. We do have a pressure sustaining valve over here. This is to avoid sucking. So if these IBC containers are below that point, you do not need it. But if it's above, it's dangerous that the dye just flows through and goes in here. So this is the reason why we have a pressure sustaining valve over here. And as I say, this high density fan pump, it's mixing up the dye very well. So at the end, you have a very homogeneous colored pulp. These are now I will show you some pump types which we are using, but this is not fixed. So we are buying the pumps from somebody else. If you have your own pumps which you want to use, we can connect to these pumps as long as we have some way to control these pumps. Could be 4 to 20 milliamps, could be OPC, could be whatever signal you want, CAN bus, Profibus, whatever you want. So we can connect to the pumps or to your DCS system. These are Brown and Lubbe pumps. These are very expensive pumps. Nice because they have a huge range. They go from 1 to 10,000 is the range what you can pump with these pumps. But as I said, it's very expensive. Normally, we do not use them for brown paper because the amount, the differences of the changes of the 3 dyes are not that much. So these pumps are very, very reliable, very expensive, and you see this is 10,000 to 1. Yeah, I would think this is the more common way now what we have. These are Grundfos pumps. It's also a piston pump, but it's a diaphragm pump, a membrane pump. You see we have here the hosing with all these valves. It's made of plastics, and these pumps are much more cheaper. So if a pump like this fails, you take it out, you put a new one in, and then it runs again. So this pump is approximately 3,000 to 5,000 US dollar. You can really easily exchange it, and then you repair it before. With the other pumps, with these Brown and Lübbe pumps, you should really repair them because these are 10,000 euros per pump or even more. So this is a very nice system. The range which they are pumping is not that big. It is only 1,000 to 1. With the Brown and Lübbe, it was 10,000 to 1. But it's also a nice system, and it's good for brown paper. And the last pump which I want to introduce is Watson-Marlow pump, which is a peristaltic pump. So this is quite easy to use because you can have different hoses, and you have a lot of different variations to add more or less dye inside. I think it's a very nice system also for brown paper mills. And they have a ratio of 2,200 to 1, which is not fine. They have no valves. They are very insensitive to dirt, and they are self-sucking. This is a quite big advantage. Maybe a disadvantage could be it's only 2 bars, but typically at that point, the pressure from the pulp is not that high. So this is some things what customers say. We were at a Korean linerboard mill, and they said they had no more sawtooth coloration, so that means going up and down in lightness because they add more or less dye. And only with this, they saved immediately 15% of their dyes. And then they switched from 1 dye to 3 dye dyeing. And this was another saving from them. And at the end, they used a darker pulp because they could not get much closer to these to the target color, and this saved another 40% of dyeing costs. So if you imagine this saving 40% of the total dyeing costs, this is a lot. And from another mill, we get the information that they saved the waste from 8. They had 8% waste before, and now they have only 2% with the inline color measurement. Of course, you still have some because you have the startup time, you have a shade change time, but we could reduce it dramatically. To be honest, I do not always have these numbers from all the mills because this is very confidential from some mills, and sometimes they give it to us, but honestly very seldom. So we do not have this. We do not have too much of these examples where we can publish it. But we have some people which made some statements. And you see here, this is Leiper-Schrobenhausen. They make colored paper boards. So it's not really brown paper, but it's a colored paper board. And they said after startup the system, the advantage that had been expected were realized soon. First, reduction of waste during grade change by 25 to 50%. They had some more things which they pointed out. And they said that a trust in our know-how is really paid off. So you can read this, and this was Mr. Martin Kaltenecker, the plant manager of this Leiper mill. And another one, Mondi Raubling. Mondi is making brown paper. So he proves really that the delta E values of 0.1 to 0.2 are realized. So you can imagine now if you have the variation on your machine and you can bring it down to 0.1 or 0.2 and make everything a little bit lighter, you will save a lot of dyes immediately. Very little maintenance effort required. I show this in one of the next slides. Mr. Habnit from Mochenwangen, they made book paper. So the closed loop control from X-Rite, we have no more complaints about color from our customers. Nice. If we talk about the installation of the system, so typically a full closed loop control system is installed within, let's say, 4 days. First day we install all the mechanical parts for the color measurement. Typically we need 2 hours of a machine shutdown. The rest of the installation is done while the machine is running. That means we install the cables, connect the cables, set up the computer, do everything. So at the end of the first day, we have a color measurement. We let run the color measurement during the first night. On the next day, we install the pumps and we install the whole closed loop color control system. For sure, there is no shutdown required on this period anymore. It depends how quick we are and how confident we are. If we are confident that the closed loop color control runs at the end of day 2, we let it run overnight and we show the operators what to do if something happens. So if everything goes wrong, which buttons they have to press to go back to the normal or regular dyeing procedure. If you're not confident, we let it run overnight just by measuring without the closed loop control, and then we make the next day the training and set up the closed loop control and find some parameters. So at day 3, we typically train 3 shifts, and during this period we do some fine tunings, and the day 4 we are only there to help the customer if he wants to do something to get to become more confident in the system, let's say. We have a very low cost of ownership for the system. So normally what do you have to do? Every 2 weeks or every 6 weeks, depends. Operators should check the instrument and the frame, clean it from outside if necessary, and perform an external calibration. So we say here approximately 30 minutes. These 30 minutes include going somewhere, taking a calibration standard, going back to the machine, do this external calibration, do the cleaning, bringing the standard back. So it's really not more than 30 minutes. Once a year, we recommend to have an on-site preventive maintenance from one of our service technicians. So somebody's coming over, cleaning the instrument from inside, doing calibrations, checking that everything works fine. We have capacitors inside which should be replaced every year. So this is done by the X-Rite service engineer. These instruments are a very long time investment. So we have instruments built in 1990, which are still in operation. Unfortunately for me, honestly, but we try to make good instruments and they last very long. We have a very high availability. So typically it's by far above 99%. It's quite easy to service, and even if the instrument fails, it can be done by the maintenance people in our customers' facilities. So we train not only the operators how to run the system, we train maintenance how to do a quick service. There are some easy service parts to replace, which they can do themselves. So this is the quickest repair they can do. And we also train a supervisor to set up the system and to know everything about the system. So we have many very happy customers who saved a lot of money. And as I said, if you know somebody, ask him how the system is working and you will for sure not get a bad recommendation. If you want to learn more about the system, you can go to the www.erx50.com. So this is especially a website for these kind of systems for different applications. So you will find here one application, which is the biggest one, is paper. And you can see all these paper things we have together on that list. So thank you very much for your patience. I hope all these answers are, or all your questions are answered. If not, you can call me anytime, let me know, and contact me. I will give you more information on the phone. Thank you.
Great, thank you. So this marks the end of this webinar. You'll receive an email with a link to the recording, so you can refer back to this and view it at your convenience. Thanks for joining, everyone, and have a great day.